Hello, my name is Lasse Rosendal. I have the pleasure of giving you a quick overview of the NextGenRoadFuels project. So I will quickly switch over to my screen and share my presentation. So the NextGenRoadFuels project is a project that's coming to its end. We started in 2018 and are finishing later on this year. And so it's a very appropriate time to share with you a few of our results and conclusions. So I will give you a quick overview of what it's all about and then go into some of the results, selected results, not everything, and then wrap up with a couple of perspectives on the technology and on the process. So NextGenRoadFuels is a hydrothermal liquefaction project. It covers the full value chain from some kind of low value organic feedstock until we finally arrive at the market side where we have a finished fuel. And being a road fuel topic, we've focused on diesel and gasoline for road transport, but we've also looked at other outlets, and I'll get back to that. Feedstocks are urban feedstocks, so waste streams from cities. So sewage sludge has been one of the major ones. Also food waste, organic pulp from municipal solid waste, and some lignocellulosics in a mixture. And we've looked at all the stages. We've looked at pre-treatment, we've looked at the conversion into a biocrude, and we've looked at the upgrading and all of the auxiliaries associated with this. And one of the things that let me also just give you the partnership. So it's quite pan-European. We have partners from north and south, west and east of Europe. And the partners cover different parts of the entire value chain, from fundamental technology in the HTL step, similar in the upgrading. We have the market side, we have LCA, techno-economics, process design, and then we have the whole exploitation side as well in the project. But to get back to the sewage sludge is an abundant resource. It's one of those resources that just gets more and more abundant as more and more countries become adept at wastewater treatment. And as an organic resource, it's seemingly quite attractive, but there is one issue if you want to make fuels, and that is the nitrogen content. You don't wish to put the nitrogen all the way through to your final fuel. And here you can see a breakdown of sewage sludge from one from Denmark, one from Germany, and one from Spain. And what is apparent is that there is obviously nitrogen in the sludge, and you can see also that most of that nitrogen is bound in the amino acids. And so that prompted us to look for an alternative value path for proteins. So we started looking at how could we extract proteins from the feedstock before we went into the traditional fuel process. And we looked at enzymatic removal, quite successful in terms of yields, but also, of course, costing us in terms of carbon that would not go to the fuel side. We also did a combination of, we also looked at chemical removal, so acid treatment, again, relatively good yields, but substantially significant carbon losses associated with this process. So yes, you can do it. It doesn't come for free. So this is one of the conclusions. One interesting factor on the subsequent HTL step was that if we did the two pre-treatment stages, that we actually got a higher specific yield out of the feedstock. But because we also had the associated carbon loss, the total yield of biocrude from the feedstock we sent on was less than it would have been. So again, there's definitely a value trade-off on this. One special feature of the NextGenRoadFuels project is that we've been spending a lot of effort on the upgrading, because the idea is not just to make a biocrude, an intermediate product. The idea is to make the full gasoline, diesel, marine fuel compound. So we've been looking intensively at the the upgrading, so the refining of the biocrude. And of course, one of the challenges in biocrudes is that we have oxygen present. So although we are working with hydrotreatment as you would in a regular refinery, we are hydrotreating to remove the oxygen. And then because of the feedstock, we still have nitrogen present. So we have to both do oxygen removal and nitrogen removal. And one of the challenges here is that these require quite different process parameters in order to remove that. So the focus has been, how do we combine a multi-state upgrading approach in order to make sure that we actually do get rid of the heteroatoms that we need to get rid of in order to make the hydrocarbon products that we want. We've been running or working with many different platforms for the upgrading. One achievement of the project is that we've actually been running continuously at pilot scale for several hundreds of hours, stable operation, everything looking good, getting quite high yields out of this, and also reducing heteroatoms as we expected. And you can see some of those shown here in the table with the red arrows. Also inorganics. We have a guard bed that removes the residual inorganics before we go to the actual hydrotreating. So you can say that as part of the project, we've successfully managed to take to cover the entire value chain that actually allows us to say that we have produced the final fuels. And that brings us to the market side of things. Ultimately, the idea is, of course, to put these fuels into the market, because the market is still dominated by fossil fuels, hydrocarbons. Our fuels have to be compatible, both with the fuel infrastructure, and this is very, very important. It also has to be compatible with the existing end user technology, so vehicles, vessels, wherever you want to put the fuel. And so this puts a number of constraints on what you put out there, and you can see. So one is the compatibility. One is storage stability, whether we can actually store it for a period of time, and the last one is energy density. And if you're in the alternative fuel business, you may know that there are lots of fuels being discussed at the moment, not all of them with the same energy density that is in hydrocarbons. And so our point here has been to make fuels that are sustainable. They are produced from renewable feedstocks. The process is sustainable. But they actually go in as synthetic versions of what we already know, so with the same energy densities, with the same viscosities, and so on. You can also see in the European Union, of course, there are estimates of fuel consumption based on different policy approaches. And what we can see is that it is expected that biofuels penetrate significantly into the fuel mix in both in terms of road transport fuels, but also in the others. Aviation is something we talk a lot about, but definitely also into the marine. And we have in the project been elaborating on these scenarios and basically what it takes to put HTL derived fuels into these markets. So there are different ways that you can do this. You can work with the raw, or try to work with the raw biocrude. You see the top distillation curve there. This is a raw biocrude. The one below that is after it's been hydrotreated. And there are many parameters that need to be considered when you want to take an alternative fuel in and either use it as a blend stock or as a full replacement. So it has to be miscible. It has to be a fuel that doesn't jeopardize any of the limits. Sulfur is one of those limits that is extremely strict. These fuels have the advantage, of course, that they are not sulfur containing. Viscosity is, again, for atomization, etc. In engines, this is a crucial feature. And so as we come, so even though we have on the overall scale the same parameters, the composition of the fuels may be different from traditional, and so we have to make sure that also our viscosity is within specs in order not to jeopardize the end use side. In terms of market access, so one part is is at the very end of the process. So how do we position ourselves according to market, but also the input side. So how do we position ourselves in terms of being an attractive pathway for the different feedstocks? And in order to explore this side of things, we in the project conducted quite a significant number of interviews with stakeholders in the Netherlands, in Germany, and in Sweden, in order to establish scenarios for implementation of this HTL process. And so we talked to wastewater treatment plants, we talked to policymakers, decision makers, influencers. We talked to the oil sector. We talked to end users, and we talked also to local authorities, municipalities, in order to establish the entire framework or set of boundary conditions that would allow us to implement a technology pathway such as this. And you can see some of our conclusions on this if we start from the end user perspective, marine sector. Even though it does fall a little bit outside of the scope of the project, we have been actually working with marine sector, because when you make a biocrude, you're not just making a specific fuel for a specific segment, you're making a biocrude, just like a fossil crude, that can then be fractionated and facilitate various sectors. So even though it is a road transport call, we've actually been keeping an eye on the marine sector. So when you ask the marine sector, yes, advanced biofuels is something they're looking into in order to reduce carbon emissions from shipping. It's more a cost scenario. So even though they are willing to pay a premium over fossil fuels, they are not willing to pay an extremely huge a premium for the green fuels, because international transport and shipping is really a marginal business. But there is definitely an interest from that side of things. In terms of the stakeholders within the oil business, then it seems from these interviews that refineries in the Netherlands and Sweden are most likely to be first movers, and we see actually this already in these countries that there are activities looking towards advanced biofuels. Whereas Germany perhaps right now is much more focused on green hydrogen. So in order to get the refineries and the oil infrastructure on board, most likely it'll be Netherlands or Sweden. And then coming to the top here, to the feedstock providers, sewage sludge is actually a feedstock or a resource that is under significant legislation. There is a lot of focus on wastewater treatment and sewage sludge in how we dispose of this material. Right now, a lot of wastewater treatment plants are looking towards anaerobic digestion, and of course, you can see that as a competition to putting it into HTL. You can also see it as something that could be synergies explored in actually combining these two technologies to get full conversion, and also minimizing some of the environmental effects of putting even digested sludge out into agriculture to capitalize on the phosphorus content. So and we see legislation coming from the European Union where already there is requirements on phosphorus recovery. You have to one consequence is that mono incineration is the route to be taken, and then this is really because we're sort of in a breakwater here on which way will legislation drive us. So there is definitely a value proposition for HTL in terms of sludge, but there is a lot of municipal regulation in Europe that has to be accounted for in order to make this happen. And one challenge you can see in the bottom left-hand corner of the figure is this European waste hierarchy. And it's some of you might know the biomass pyramid, where high value is at the top and at the wide bottom, this is low value, so energy is typically at the bottom. Here, one of the challenges is that a technology such as HTL falls under recovery rather than recycling. And here you also have, so the value keeps going down. So the highest value in the waste hierarchy is to prevent the waste. Second highest is you have a reuse thinking in your product. Recycling is next, and then you go into recovery, and then you go into disposal. Disposal, of course, is not where you want to be, but recovery is also not so attractive. So the best place to be would be go into recycling, to say, well, we're actually recycling carbon, we are recycling phosphorus, etc. But currently, this is one of the challenges that you face. So it's not so much the technology, it's more the way that it is being viewed by authorities. But in terms of potential, so you have, there are two ways we can do this. You can have a standalone setup where you have an HTL plant with upgrading connected, or you can have a number of HTL plants that then feed into a centralized upgrading facility. And when you look at the sort of overall and the carbon footprinting of these, it seems that a centralized location is the one that is more attractive. So that brings me to the very final conclusions. Yes, nitrogen is a challenge when you look at the urban feedstocks. It is one that can be handled, but it is certainly something to consider. HTL is definitely effective for valorization of these low value input streams. We've managed in the project to shift from very much focus on the primary stage to actually look at the entire value chain and to have final products. There is a lot of legislation that is complicating the implementation of HTL, and this is also something that needs to be addressed. And finally, that a technology such as HTL has the advantage that it is actually covers the full range of transport modalities in the products that come out. So on that, I'd like to thank you all for your attention and open for any questions, if there may be such. I don't see any questions, so nobody can see that, but I'm looking at the organizer now. Okay, well then, thank you all for your attention. I will stop the screen sharing and wish you a good continued conference. Thank you.